Swayam Prabha. Digital India. Educated India.
Welcome back, my dear students, and this is the 30th class, and we are continuing the discussion of GERT and how it is different from PERT and what are the implications for the exclusive OR, implication for inclusive OR and the AND networks. I know that I am basically going a little bit slow trying to discuss many things, but the reason is that GERT or QGERT are interesting topics, very rarely used in the project management concept, but they have huge amount of implications that if you are able to implement that to the maximum possible extent with all the implications, all the actual concept brought into the practical phase, GERT really gives you a very good picture how it can be solved in a practical way, considering all the concept of probabilistic network to the maximum possible extent. Probabilistic means, again I am repeating, the probability related to the time and probability related to whether that particular arc or whether that particular route would be taken. And also if you remember in GERT we also mentioned time and again the looping concept. So, we will be, as we were discussing in the last class when we just finished that lecture, which is the 37th one about the basic network concepts. The second point is the concept of feedback is only appropriate for the exclusive OR input type of node. So, the first one if you remember was where you could basically replace a complicated network with the equivalent simple network, which I did mention and tried to basically bring a simile where you are able to replace a decision tree with its equivalent certainty equivalent value. So, that was may not be very direct, but that should definitely give you a essence that how the equivalence concept I am trying to bring into the picture for the GERT concept. So, continuing with the second definition, second explanation. So, this results which I just read, this results from the fact that the feedback requires that the loop node being returned to the realized prior to the feedback. So, obviously looping would be there in order to give the feedback to it to its initial stage once again before it starts again. But the node cannot be realized if it is an AND type. The reason being that if it is basically an exclusive OR, which means the loop would be coming back time and again such that the looping is taken care of. For the AND one, it has to be either if you remember the maximum one or the realization of all of them. But if one of them fails, then the whole process would not work. So, in this case the exclusive OR would be in a position to take care of that looping such that reality or practicality can be brought into the picture. For the inclusive OR, so what I mentioned was for the exclusive OR, for the inclusive OR input type only the branch representing the first activity completed is significant. All the other branches are ignored in computing the time the inclusive OR is realized. Since a feedback branch will always be completed after a non-feedback branch, the exclusive OR representation can replace the inclusive OR if a feedback branch is incident to the node. So, what actually means is that when you are considering the exclusive OR and the inclusive OR, if you go back to the truth tables like 0 0 and how 0 0 in one case can lead to an output or the truth statement in the example which I discussed or the example which we did talk about during the class. So, that would basically make a sense in the statement which is just mentioned here. So, which basically means that the feedback will always be completed after a non-feedback loop is there. Hence, the exclusive OR representation can replace the inclusive OR depending on how the whole sequence of events of the activities are scheduled. The third important point is that if all the nodes have exclusive OR input characteristics. So, the inputs I am only consider are the XOR, the exclusive OR, then either all node outputs are of probabilistic type or the paths, that is the collection of the branches following a deterministic output, are independent, that means they are not touching and it is joint. So, this will become clear as we proceed and solve or try to discuss the problems in details. If this were not the case, then at some input side of the node there would be possibility of two branches being realized simultaneously, which may not be at all possible in the case of a GERT network. That means practically impossible situations can come up if we do not consider the third point which we are just discussing. And this would contradict the condition that all nodes of the network have exclusive OR input. So, what it means that if you consider the exclusive OR input characteristics, based on that if you proceed and do not consider those assumptions which were just mentioned, so the end result which we will get would basically contradict the truth statement of the exclusive OR based on which you have proceeded. So, obviously it would mean that the condition based on which we are trying to achieve the exclusive OR should definitely be right. This basically you are trying to prove it through the negation concept. The fourth characteristic is, fourth one states that for some network and an inclusive OR. So, we are always coming back to the exclusive OR, inclusive OR and statement time and again the input and the output concepts. So, the and an inclusive OR input types can be converted into exclusive OR relationship depending on how you frame the overall logic statement. To illustrate this, each of these relationship is discussed in a quantitative framework. For the exclusive OR relationship, we have this diagram. That means, the conversion of exclusive OR, inclusive OR and depending on how you are able to basically convert the truth statement would be considered. So, here you have basically a network. So, if you consider the networks, the probability p suffix a and t suffix a, probability p suffix b time t suffix b are given. And if you remember this triangle which you have 1 and 2 number and the triangle, this the mirror image of the triangles which you have on the right hand side with a vertical line, it will definitely give you informations of what they are, all the combinations of 6 which you have done, exclusive OR, inclusive OR, the deterministic one and corresponding to the and the probabilistic one for the input and the output. So, if I consider the overall probability and time, which is most important for me, why? Because if you remember, the main characteristic based on which we started discussing the GERT was basically main two attributes. One was basically time, one was probability, because probability and time would give me the whole structure, that what would be the time taken and what would be the probability that those paths would be achieved. So, for this one, when you are considering the overall probability, it would basically be a simple multiplication of the concepts of P1 into PA plus P2 into PB, which will give me the probability P3 for that particular node. And the time would basically be a collective time based on the overall weighted average. So, what are the weights average which I am considering? It would be, so T1 and T2 bars are the average times. So, average basically is denoted by the bar T3 bar, T1 bar, T2 bar, so on and so forth. And this concept of small t suffix a, small t suffix b, small t suffix c corresponding to whatever different type of nodes and inputs and edges you have, they would basically denote the time. So, based on that we can find out the value of t bar 3, so bar means the average, and based on that we proceed. So, now if it is expanded, made into 3 nodes, 4 nodes, 5 nodes, or say for example, exclusive OR being more complicated with many exclusive ORs, many inclusive ORs and nodes, so they can be done accordingly. So, what are these? So, now I will basically explain once the diagram has been put into in front of the candidates in the last slide. So, these are where P capital P. So, remember this is the capital P, where capital P suffix I is the probability that the node I is realized, point 1. capital T suffix I with the bar is the expected time that node I is realized. So, node 1, 2, 3, 4 whatever it is, it will basically have the corresponding probability and the corresponding time given by the suffixes. For this introductory discussion, only the expected time for a node can be realized. Given it is realized, it will be calculated. Note that even now coming back to the statement, if small t suffix a, small t suffix b may be constant, the time to realize node 3, which is capital T 3, is a random variable, because these times which are given are on an average. When we basically try to find out, they would basically be, this t bar 3 would be the average of the realized values for the random variable. So, let me try to basically simplify that. T bar 3 consider, or T bar whatever it is, consider you have a die when you play the game of Ludo. So, the die has 6 faces, and consider it is an unbiased die, the 6 faces are marked 1 to 6. So, before you roll the die, the face which is coming out is totally unknown to you and is a random variable, and let us denote it by capital X, as is the notion in probability sense. Now, once the die face comes out and we note it down and know it, then it becomes a realized value which now becomes fixed, and it is given by the symbol of small x. So, capital X is before you start, which is a random variable. When it is realized, it becomes a small x. So, when you are trying to find out the average of x, capital X, and we denote it capital X bar, it is technically the value of, for this example which I just discussed, would be 1 plus 2 plus 3 plus 4 plus 5 plus 6, that is the actual sum of all the values which can come out when you roll the die, divided by 6, because 6 is basically a number of such occurrences are there. And if somebody wants to basically have a look at this picture in the different way, it would be 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6, where these 1 by 6 are the corresponding probabilities. Point 1. Point number 2 is that, considering that I am trying to basically expand my thought process and try to bring to the fact that why T3 can be a random variable. The average value can also, even though it is not mentioned here, but average value can also be a random variable in this sense. Consider you have a box, and the box has numbers, chits marked 1 to 5. Now, if I tell you that what is the average, if I pick up each of them chit once, note it down and keep it in the box, that is, I am doing a random sampling. This is a concept I am just utilizing from probability for the first time. Do not be bothered too much about the words which I am using, try to understand the problem or significance of the problem with respect to what we are discussing. So, consider that that chits has a average value which is 1 plus 2 plus 3 plus 4 plus 5 divided by 5, because the probability of getting any one chit is always 1 by 5. Now, on the other hand, consider I change my setup of the experiment. I pick up 3 chits at each time with replacement. So, what it would be? In one instant, if I pick up 3 chits at one at a time with replacement, it may be possible in one scenario, the first chit is 1, the second chit is also 1, the third chit is also 1. So, what is the average? Average is 1 plus 1 plus 1 divided by 3, which is 1. Now, consider I repeat this experiment, which is being done by the same person or different person in the same setup, and he or she picks up 3 chits with replacement, no problem, every setting is same. It may be possible at the other extreme, the chits which come out is 5, 5, 5. In that case, the average value of that particular sample which you pick up, I am using the word sample for the first time, but you can check up any simple concept of probability, that will become much easier for you to understand. A sample is basically a small set of the whole set of things which we have. So, in that case, the average of the sample is 5 plus 5 plus 5 divided by 3, which is 5. If I consider this number 1 which I just mentioned, average, and number 5, in the long run they seem to be average, but they are random variable themselves, because if I keep picking up observations, the average would change. So, in the sense that the average concept which is written here we will consider them to be deterministic, but they can be sequences where or the outputs depending on what type of example which you have, where the realization has not been realized, that means all the values have not been realized to that extent where all the possibilities have been looked into, such that the average can be random 0.1. But remember that the averages of the average in the long run should actually be the bar value which is deterministic. And just to wrap up this discussion here, the averages of the averages or whatever you take in the long run should be exactly equal to the population. Population means the whole set of observation which you have. For our example, they were the chits 1, 2, 3, 4, 5 collectively. So, it will basically be equal to the actual population average. So, continuing our discussion is that note that even though T A, T B may be constant, the time realized for T 3 is a random variable, and so can T 3 bar be, but do not be too much bothered about that. The derivation of P 3 and T 3 is by enumeration of the possible events or different type of events or outcomes which you can have that result in the realization of node 3. Thus, node 3 can be realized if either branch A or branch B is realized. So, whatever different type of inputs which you have, which is in this diagram, branch A with probability P suffix A time T suffix A, branch B being probability P suffix B and time T suffix B is there. So, these are only two, they can be more than two also, that would only make things complicated on the calculation front, but the concept remains the same. So, the probability that a branch will be realized is the probability that node 1 is realized, which is P capital P suffix 1. So, this small p and capital P would now become clear to you. One is probability along the edge and one is probability of the realization of the node. Edge means the arc. So, node 1 is realized with capital P suffix 1 times the probability that a branch A is realized given it is P A. So, when I am trying to find out the probability, it will be multiplication of the probabilities of P capital P suffix 1 multiplied by small p suffix A. Now, if I have two branches, it was what? Capital P, if I go back here, capital P suffix P A, then capital P 2 into P B. Now, if there are more nodes, the calculation would just be repeated accordingly, where you basically bring the node probabilities and the realization properties accordingly. So, a similar discussion holds for branch B and the equations P 3 B's capital P suffix 3 would follow. Note by definitions of the exclusive OR relationship, branch A and B cannot occur together, which is basically as per the concept of exclusive OR. Obviously, if you change inclusive, bring into the picture inclusive OR, and obviously the concept would remain the same, the way of calculations will differ. So, if this was possibility, then node 3 would have to be an inclusive OR node, and based on that you will basically do your calculation. The expected time to realize node 3, given it is realized, that means it had been achieved, is the weighted sum of the possible times to realize node 3, and the weighted sum which we just saw and which I did mention very fleetingly. Let me go back here. So, I mentioned the last equation was the average. So, it is basically a weighted sum. Weighted sum what you are taking is the probability of this realization multiplied by the time. So, if you see the numerator, you have times, that is T 1 bar plus T suffix A, which is the time realization of the node and the arc multiplied by the corresponding probability, which is P 1 into P A, and the second realized values is T bar 2 plus T B multiplied by its corresponding probability, which is basically P 2 into P B. So, that is the weighted probability values which you have. So, it would basically be divided by the probabilities which you have here in front of us, which is P 1 into P A plus P 2 into P B. So, now continuing our discussion, if node 1 were the same as node 2, then obviously P 1, so this capital P 1 suffix P 1 will be equal to capital P suffix 2, and hence the average T1 bar and T2 bar would be the same. So, in that case the following equation would result, where you can find out P3, which is capital P suffix 3, you can find out capital T bar suffix 3, and the network can then be drawn as shown here, where you will basically have one connecting 3 the nodes, and with an arc or path where the corresponding probability and time would now be replaced by the corresponding probability and time which you have just calculated. So, what is P suffix E is sum of PA plus PB, and the corresponding time would be given as just calculated. So, in this case, sorry, I just went very fast into the next slide, but I wanted to mention. So, if you see the last diagram, it gives you nodes are being connected by the arcs, corresponding probabilities are given, and just as you do simple calculation to find out the average value and the sum of the probabilities. Now, consider next the AND logical relationship. So, we will basically try to go through the logic relationship and try to highlight how the average value can be calculated. Now, the AND value calculations would be based on the fact that the probabilities and the time would be given accordingly. So, if you have the values as given, so consider is a very simple decision tree, the diagrams are exactly the decision tree, but the concept what you are trying to utilize in the decision tree, whether you take that path, whether you do not take the path. If you remember the example of drilling, whether you will drill or do some seismic test, or you will come up with a product in the market, that moped one, whatever it is, or you want to do some pre-marketing of that, try to understand whether it really sells, is exactly what is given here as we are considering. So, you have 1 comma 0 for the node which from S to 1, and it is also 1 comma 0 from S to 2. So, this 1 and 0 are the corresponding values which we have already discussed for the probability and the corresponding to time. Now, as you proceed later on from node 1 and 2, depending on the concept that is an AND logical relationship, you will find out now you will basically have the time and probability coming into the picture, but remembering that fact that the probability of sum of all the probabilities of all the paths should exactly add up to 1, as it should be as per the normal nomenclature and by the basic concept. So, if I consider that and lay attention to the so called 2 paths or edges which are joining 3, I am just mentioning 3 as a number, and people should be able to see the node which is there. So, it has a probability of P suffix A comma T suffix A, which is the probability in a time, and then corresponding to the fact that 3 is being joined by 2, the corresponding probabilities are P suffix B and T suffix B. And if you see the alternative arcs which are going out from 1 and 2 separately, obviously one would be 1 minus the probability for the path which is joining 1 and 3, and for the other path which is the bottommost one which is going out from 2 and not joining 3, it would be probability would be 1 minus the corresponding probability, which is 1 minus PB, where PB is the probability joining 2 and 3, and the corresponding times would be given accordingly. Node 3 will only be realized if both A and B are realized, because corresponding to the fact that the AND network is in force or the logic is in force. The probability that it is realized would be, again using the same concept, would be capital P1 into small p a suffix a, those two values multiplied, and the probability that B is realized would be similar in the same way, capital P suffix 2 into small p suffix b multiplied together. The probability that both are realized is the intersection of the concept that both of them are realized, because it is an AND network. So, if you go back, if I did not want to mention that, I am sure that would not be required. If you consider the concept of exclusive OR, inclusive OR AND network, it would have some implication due to the fact that the Venn diagrams could be utilized in order to explain this concept of logical operations. So, in this case, continuing the discussion, in this case the intersection of the events associated with nodes 1 and 2 are denoted by P1 intersection 2, that means both of them are being realized accordingly, and it will be equal to P1, and similarly when you are doing it for PA intersection B, it will be basically probability PA into B corresponding to the fact that they are happening such that the probability should be multiplied. And again if I want to find out P3, it will be multiplication of the first term, which is basically P1 multiplied by the multiplication of those terms of PA and PB, because now it is basically the AND network. Similarly, if you remember the AND network, and I had discussed in this class when I had gone to the characteristics of the nodes, it was basically maximum time. So, if I come to T3, it is basically the maximum time which is occurring, and we will take that value which is more. And what are those values? Ta plus T1 plus Ta as the first part, because that is the node which is joining, as I mentioned, the node 3, one of those edges, and the second one is T2, capital T suffix 2 plus Tb, and based on that you will take the maximum of that. If there are 3, you will take the maximum of these 3. And corresponding to the fact that how we will do the calculations or probabilities, it will be again the same thing. In this case, I have used, where I am pointing my finger, if you note down, it is P1 into PA into PB, corresponding to the fact if you have 3, it would be the second part would be PA, PB, PC, and correspondingly P1 would be calculated accordingly. Care must be taken here in the computation of the expected value, since the expected value of a maximum is not usually the maximum of the expected value. So, this is just for the information, and be careful about that. So, this will be discussed in later on, but I do not think that is very much necessary for this course, because it is not an exclusive detailed discussion about GERT, but is more of a cursory discussion how you can basically build up the network using the GERT concept. For this case, you will basically have T1 is equal to T2 is equal to Ts, we are taking a constant value, and we will have basically T3 is equal to Ts, and basically maximum of the two other values, which is T and Tb you are taking. Based on that, the probability will also be calculated, which is Pb, Pa into Pb, and then the maximum value would be given as Te would be equal to max of Ta and Tb, and you will basically do the network accordingly. Now, before I go to the next slide, I try to basically summarize what we are doing is trying to basically go into the nitty-gritties of the AND, the exclusive OR and the inclusive OR, and try to basically see the how the calculations can be subsumed and brought into the forefront for any network, such that combination of any network with any edges and any number of arcs can be done very practically, considering both time as well as the realization of the networks or the arcs are probabilistic. And obviously, you will understand the logic of AND and OR should be taken into consideration when you solve the problem. So, coming back to this diagram, so what you have is S is leading to 1, S is leading to 2, S is leading to 3. So, 1, 2, 3 have their implications if you consider the diagram, and the probabilities are given. One is 1 minus Pa, and for 3 going out, for the R going out from 3, it is 1 minus Pb, and the corresponding times are given. In the first one is Tc and third one is Td. But if we consider the node 2, it is leading to the combination of the node which is a triangle with a vertical line on the left. So, I will leave that for your explanation to get it clear, but its corresponding probability is Pe and time is Te, which we have just considered as given. So, in case, say for example, it was not 1, 2, 3, but it considered it was 1, 2 on the top, then 3 and then 4, 5. So, obviously 1, 2 would have their corresponding probabilities and time, and similarly 4, 5 would have their corresponding probabilities and time, and the value of 3, which is now the middle one in the thought out example which I am discussing, would have the corresponding values calculated accordingly. So, with this I will close the 38th lecture, and try to wrap up GERT and some concept of GERT and do a very simple problem from the point of view of GERT 1 in the last lecture, which is the 40th one, and try to basically summarize in the 40th one in few minutes what we have covered and what we can expect in general from by the students in trying to basically do this course. Have a nice day and thank you very much for your attention.